What's going on? My name is Brandon with Lux Lighting. We're here with Brent Nichols, General Manager of Lux, and Morgan Pattison, an advisor for Lux Lighting for the last year. Morgan, can you kind of go over your background and where you come from in the LED industry?
Yeah. Hey, what's up, guys? So, yeah, I've been working in LEDs and LED R&D for 15 years since I got my PhD. I have a PhD from University of California, Santa Barbara in material science, and my thesis advisor was Shuji Nakamura, who invented the blue LED and got the Nobel Prize for it in 2014. So after grad school, I've been working in managing R&D for general illumination lighting as the whole industry transitioned from incandescent and fluorescent and HID to LED technology. And then through that work, I was doing some work with the USDA, Department of Energy, and started tracking horticultural lighting applications. And then I hooked up with Lux.
Nice. Now I know you do some consulting with the state of California. What's your role on that, or what does that look like?
Yeah, no, it's I cross paths with some of the regulators, and they check in with me when they're coming up with new standards, new performance standards, to make sure they make sense. I mean, they check in with a lot of people, but I've got a little bit of a relationship with them, and they'll say, hey, can LEDs achieve this efficacy? And it's like, yeah, no worries. And, does it make sense to transition? And, I'll give them my thoughts.
Yeah, right on.
For sure. Yeah, I remember sitting in on a call with you on one of those commission boards, and there's a lot of concern out there, especially like from the cultivator aspect, about switching from HPS and going into LED, and brands building their identity around HPS, lighting technology and the characteristics that particular lighting gives to plants. In your research, how you guys studying like plant morphology and looking at, how LED compares to HPS, and have you seen any, gains in that side of it from a research side?
Yeah, for sure. There's nothing magic about it, right? There's photons made by HPS, and there's the influence of the HPS fixture on the environment and temperature, and then there's some leaf heating that goes on, and so you can replicate that with LED, and you can actually do better if you know what you're doing, right? And if the cultivator knows that it's they have to make adjustments too, right? So they're losing some heat, they're losing some wattage in their cultivation space, they're losing some radiative leaf heating, and so if you make those adjustments, and then you have, if you can have more effective photons, a better spectrum from the LED technology, then you're going to do better. But you can't just make a swap and expect it to be exactly the same.
That's an interesting sentence there. More effective photons.
Yeah.
What do you want to? Can you elaborate on that for us a little bit?
Well, yeah, it's a little bit of a developing understanding, right? According to how we measure the performance of a horticultural light fixture, which is basically any photon between 400 and 700 nanometers, counts the same in terms of micromoles. But you need to have some balance there, and you can't just have all monochromatic photons of one wavelength. And it's good to have a spread. Plants like a spread. They like a certain amount of blue and a certain amount of red, and even some green photons, right? And green helps the cultivators so they can see what's going on, so you don't have to live in a blue-red world there. But yeah, you have to find a balance with the photons. The plants, frankly, prefer red, but you can overdo it easily.
Yeah, we've been learning that the past year on our testing that we've done over at Jungle Boys. With this new 2023 regulation on efficacy. What's your thought on that? I mean, you've seen a lot of cultivators getting worried that they're going to have to switch out their lights. You're the expert, so what's the deal on that?
Yeah, I don't know exactly how that's going to work, but in 2023, for new construction, that's where the standard's going to apply, right? And I think it's at 1.9. They're thinking 1.9 micromoles per joule is the standard. So
For greenhouse, correct? 1.9 micromoles for greenhouse, and then I think it's 2.1 for indoor.
Yeah.
okay, that's
Yeah.
right. Yeah.
Yeah.
So that's an easy standard to meet with LED technology. We've seen some HPS systems that could be made to do 2.1 or better, but it's only for new construction or large retrofit. So if you have an existing setup and you need to change a light,
More
no
than
worries.
10%, I
Yeah.
believe it is. If you change
Yeah,
more
so
than 10% of
so
the lights.
growers aren't going to be having to take down lights in 2023 and put up more efficient lights. They can still run their HPS just the same. It's just after 2023 in California, you won't be able to hang 2.1 or less.
Yeah, that's how I understand it.
Yeah. Yeah. No, that's we've been doing a lot of testing the last 12 months, and we're going back and forth, and we're seeing a lot of these newer LEDs that are central focused on energy output and kind of have the form factor of an HPS, but they put it in an LED fixture, which is forcing you to raise the light 3 to even 4 foot above the canopy. And then you're also having high output LED systems that have a similar form factor because of the wattage. You're seeing 1,000, 1,200 watt LED, and you're having to raise those above the canopy 3 to 4 feet. What's your thought, and what's the direction that you're seeing is the best form factor for LED with those two platforms?
Yeah, so in general illumination, we've seen this where people want the LED technology to look like and act like the old technology. And that makes it simple for, a homeowner to swap out a light bulb, right? And you get a more efficient light source. But what that does for general illumination and horticulture is you end up kind of having the worst of both worlds. You have the technology limitations of the old technology that you're trying to make the LED technology fit into. So with the HPS example, if you're trying to make LEDs look like an HPS fixture, what you end up doing is jamming a bunch of LEDs close together, which heats them up. And then you get them real close together so you don't have a good optical distribution and you don't get the same uniformity at the canopy. So, the better direction I think is these like arrays of bars that create different places where the light's generated, and you have different angles of light hitting the canopy and penetrating into the canopy. You've moved the LEDs away from each other so they stay cooler. And it's easier to manage their temperature, and you can get the fixture, a lot closer, which helps. You can get, higher PPFD that way. So it doesn't make a lot of sense to me short term or even long term to try to make to shoehorn LED technology into the old technology form factors. LEDs and LED fixtures should look like what's best for the technology, not like what people are used to.
And what would that look like? More spreading energy across a large surface area?
Yeah, I think you want to spread out surface so you have the light coming in at a lot of different angles, and you have the LEDs not too jammed up, heating each other up and interacting with each other. So it looks like, frankly, like the Lux 645 and products like that, linears that have high intensity that you can put close to the canopy.
Yeah, it's an interesting concept at the moment. I was reading a website yesterday. I was doing some research in the UK on some price of some lighting, and I saw a statement on there: for every 1% reduction in PPF output is a 1% reduction in yield.
Yeah.
It's literally this is a statement that's being made, and it seems like people are being influenced into like going back to the high output, right? High watts, because that's going to equal yield. Whereas we're using 645 watts to produce over 1,000 micromoles at the canopy, and we're getting comparable yields to 1,000 watt HPS. So it seems like there's a change going on. Like, the market's influencing people to purchase a product that is designed to work in an opposite way.
Yeah, I mean that's what's super interesting about horticulture is that light yield is proportional to the PPFD, right?
Mm-hmm.
And LEDs get you more PPFD per watt, right? And then you can control the environment, right? It's worthwhile controlling the environment for this crop. Basically having almost perfect control.
Mm-hmm.
So then people, the old days or the old thinking of PPFD, we're going to saturate photosynthesis at a certain PPFD level. When people keep going beyond that and beyond that. Cannabis loves light. It's like the more light, the better. There's practical limits to getting there, but a lot of good products are putting out more PPFD with good uniformity, with better spectrum, and that's definitely the way to go.
Mm-hmm.
Can you go over I know you know the terminology, but the inverse square law?
Sure. So when you have light coming out of a source, it spreads out. It covers a certain area. That whatever that amount of light is, it covers a certain area. And as you get further away from the source, that area gets bigger, so your PPFD goes down. And so basically, if you're 1 foot away from a light source and your light's covering an area that has a radius of 1 foot, right, then your area is like pi r squared. Now, if you're 2 foot away and your radius is 2 feet, pi r squared, that r squared, you're 1/4, because PPFD is per area. So the further you get from the light source, the lower your PPFD is going to be.
Okay. So having a high output LED hung, 3 to 4 foot above the canopy will give you a similar effect as a lower watt output being hung closer to the canopy, like 12 to 18 inches.
Sure. Yeah. And what you're going to do too is you're going to have a uniformity problem because, right underneath that fixture, you have a hot spot. You have the highest PPFD right there. But then as you go away from it, you're going to have, it's going to drop off quick, right? And that's just what we've been talking about with the uniformity and the spread. Having multiple places or bars where the light's being generated and delivered from minimizes that and keeps your PPFD high and uniform.
Mm-hmm. For sure. So I guess the concept is they're turning up the watts, you know what I mean, to power those chips. And so how does all that heat affect chips?
Yeah, LEDs don't like to run hot. They efficiency goes down,
okay,
and the lifetime goes down. And so, some of these products where they've jammed all these LEDs together real close, they have to use different LEDs, different LED packages, which aren't as efficient as the most efficient LED packages, which are the mid-power 3030 LEDs. So they have to use different packages that aren't as efficient and then run them hotter, which degrades their efficiency even further and degrades their lifetime.
Okay.
Yeah, we've been doing a lot of tests with UL Labs recently, sending our fixtures in, sending other fixtures in, and doing 82-day tests for 1,000-hour runs. And we're kind of seeing which are the best diodes. And, in the research that we've done, what diode companies have you been, leaning towards, or what have you've been liking that on the tests that we've been doing with UL Labs?
Yeah, there's a handful of the best LED companies out there that can make the best LEDs. Not all of their LEDs are the best, but their best LEDs are the best, right? And we like Lumileds, we like Samsung, we like Osram. There's a couple other companies that make good LEDs. Nichia, which is where Shuji Nakamura worked when he invented the blue LED. And Cree makes good LEDs, and I'm sure I'm missing some others. But you got to look for LEDs that are efficient, have good reliability and lifetime, are good value and pricing, and a company that you want to work with that you can engage with. So I think it's something you have to always watch, because they kind of each of these good LED companies makes advancements and makes little improvements, and you want to keep up with that in these horticultural fixtures, because honestly, in horticulture, efficiency and performance is so much more important than general illumination. We pay more for that efficiency, because just like Brent was saying, 1% improvement is 1% more yield, and that's a lot of money.
Yeah, for sure. Can you talk to us a little bit about how LEDs are born? It's really interesting, because we've got, we always hear of these different manufacturers, and there's different grades, and there's different bins. So, do you want to talk us through that process?
Sure. Yeah, it's kind of funny, because when you talk about making an LED, we talk about growing the LED, but it's a crystal growth process. So this is a crystal material, a semiconductor crystal, and it's a special material that's really only come into play with LED technology. It's called gallium nitride, and you have to grow it in a crystal growth reactor called a metal organic chemical vapor deposition reactor. And you grow them up at like 1200 degrees C, and you flow gas over a substrate, and you basically put together this semiconductor structure. And you're doing this while you're spinning around a 6-inch substrate, or 5 or 6-inch substrates. I don't even know what the scale is now. And so you're trying to grow these nanometer thickness structures at 1200 degrees C while flowing gas. So it's like, it's kind of like growing a plant. Everything's got to be just perfect. And when it's a little bit off on the edge of the wafer, the temperature is at 1 degree different than the center of the wafer, the performance of the LEDs that come from that portion of the wafer can be a little bit different, right? So then the LED manufacturers take this wafer, they cut it up, they put electrical connectors on it, they put it into a package, and there's different LED package types. And then they grade the LEDs, and they end up in different bins based on how efficient they are, what their color is, and what their voltage is. And so then, as an LED buyer, you have to go and look at, okay, what's the best bin from the best LED company, and a top bin from a medium LED company might be pretty good also. But with horticulture, you really just want to use the best bin from the best LED companies.
Yeah, it's really interesting. I love hearing that story. To bring it back to the UL testing that we've been doing. What did you have that statement like? Not all LEDs are equal, because it really comes down to the bin selection. If you're getting a top tier bin, and during this age testing, we're not seeing a degradation in those diodes. If you're buying an LED that uses, average LEDs or average diodes, we're seeing a 1 to 2% come off inside that 1,000 hours.
82 days.
Yeah. So if you're 2 years into your fixture, you're already going to be down, between 8 to 10% on total light output. And, when you bring it back to that, one degradation in light source, is equivalent to yields, you're going to start seeing yields come off the bottom line. So selecting an LED that uses top manufacturer, top bin diodes is just crucial to the ongoing performance of the fixture.
Yeah, and taking care of it, having good thermal management in the fixture, and having the fixture, be protected. And also the LEDs need to be protected from sulfur, and there's certain packages that have that kind of protection that you got to check for if that's in the environment. So that can degrade the reflective surfaces in the LED.
It's called vulcanization, right? Is it the
Yeah,
correct
I
terminology?
think anti-vulcanization. I mean, there's
Anti-vulcanization,
different LED
yeah.
companies do it a different way, but yeah, for human lighting, for general illumination, the end of life is considered when either when the light craps out or when it's 30% off of its original light intensity. Because as humans, we can see fine over such a wide range of light intensities, but with plants and with horticulture, 1% light output degradation is 1% less yield. And so the standard in the industry is Q90. It's like 10% off, and you're throwing that light away basically, which is completely different than general illumination. So in horticulture, efficiency is more important, reliability is more important, and the products just have to be a lot better, which is super cool. And so that means in this industry, this is basically the cutting edge for all lighting. It's brought up red LED performance, this application, and brought up white LED performance. All of the best LEDs are going into horticulture right now.
Yeah, going to that spectrum and the test that we've been doing at Jungle Boys. I mean, you said it. What do you think? What do you think about what we're doing over at Jungle Boys on thousands of lights, multiple rooms, multiple spectrum, multiple PPFD? I mean, have you ever done? Do you know any other companies doing anything like this? Have you ever done anything like this? Like, what's your whole thought on that? What we're doing?
No, there's nothing like it in the whole world, right? So most horticulture science is done at universities, and up until now, even now, it's hard for universities to study marijuana. There's only a handful of places that can do that, and a lot of times they're limited to doing research on hemp, and even that's like just been happening for a few years. And when they do a study, they're doing a couple grow chambers, highly controlled conditions to learn the underlying plant physiological responses to light. They're not scaled up. So that gives you hints like of what could work in a production environment. And then, light companies have done their studies, kind of onesie twosie, small scale, and a lot of times you don't know how good the growers are, and if they're getting an improvement under a certain light, what's their baseline? How good were they to begin with? So what we've been doing is we're taking the best LEDs in the world, new spectrum that we're getting hints from the academic researchers about what to try, doing it at scale at the best grower in the world. So there's nothing like that, and it's hard work. It's not like an easy path. There's ups and downs with doing it, but at the end of the day, when you find something out, it's real, and that's good and bad. But it's like it shows you what path to pursue in development, and maybe some paths that you don't have to pursue anymore.
Yeah. No, it's been crucial. I think that's kind of what sets the Lux team apart, is the ability to actually touch the plant at scale in Los Angeles. It's just right there. So we have Matt, the head of design, making trips down nonstop, taking data points. Do you want to go over some of the data points that we took and what we saw, on THC testing and just overall, what we were focusing on through some of those testing?
Sure. I mean, some of it's in progress still, but basically what the hypothesis was that we started with was, plants like red light. What's the most red we can pump into the plants and see how they respond. And on the flip side of that is the red LEDs are the most efficacious LEDs for generating photons. So that's a good match. If you can maximize the red, and that maximizes the plant growth, you get efficiency and productivity there. So we've been trying some really heavy red recipes, and the results were crazy, but at the end we saw some downside, some bleaching, but right up until that happened, the plants were growing like crazy. THC levels were good. So what that tells us is, okay, we kind of knew this. Spectrum matters.
Yeah. Yeah.
Spectrum matters, but you're kind of playing with fire too. You know, you it matters, and then it matters a little too much. So, you know, that's what we're figuring out. And you know, when I can, I go back and talk to my academic friends and see what their thinking is and how this matches up with their plant physiological understanding. And then we try it again. We make an adjustment and try it again.
And then you come back to Roach and then see what he's thinking and what's going on there.
Yeah, it's like, you got to connect all the dots, right? You got to connect the LED manufacturers and the best LEDs with the best, latest academic research and thinking, and with the best growers. You know, that's what's really unique about this team, and why, you know, I'm happy to be part of it.
Just wanted to throw in there. There seems to be two kind of camps in the LED industry. You got the PPF guys or the PPFD guys, and then you got the Spectrum guys, right? You know, what's your thoughts on those two fields? You know, obviously we're really digging into the Spectrum side of things at the moment, and you know, reds and wavelengths, which you know is, I think, where the gold is. You know, but where do you see it sitting? You know, and what's the academic sort of chat around those two? You know, those two insights to growing.
Yeah, I mean, I think what happened is, in the early days of LED horticultural lighting technology, the lights were underpowered compared to HPS. So they just had a lot less output. And so the LED companies would come in and say, yeah, we have less output, but look how we match up with the photosynthetic action spectrum. We match it better. So it doesn't matter that we have less output. That's not true. You gotta have the photons, right? You know, and plants to a certain degree are you know, to first order insensitive to the spectrum, because HPS works, right? If you match HPS spectrum up against the McCree curve, it doesn't fit that great. But everybody knows HPS works, right?
Yeah.
So
Crushes.
Yeah. So it's great. You know, so you know, you get these LED companies saying, hey, you guys are doing it wrong with HPS, and our light that puts out 20 or 30, 40% less is going to do better. And that's not right. You know, and I used to call that magic spectrum. There's no magic spectrum that'll overcome that much less light. So now we're at a different phase in this whole development process where LEDs can put out, you know, much more light. They can match the output of an HPS. You can get the lights closer because they're not generating that heat. And now we can circle back on spectrum and do it right, not to overcome a PPFD deficit, but to get the PPFD and then a basic PPFD deficit.
Yeah, for sure. I get this question a lot. Does your LED have IR and deep reds?
Oh, this is good.
Yeah. No. Far red works.
Yeah.
And we need to test that out.
Yeah.
It's, you know, Professor Bruce Bugby. I just got an email from him actually this morning, and he's like sending an opinion letter to one of the journal articles that said we should be including far red in the PPFD counting, right? As part of the standard, we should be going out to 800 nanometers, not 700 nanometers in the definition of PAR. So, and he's got this research, you know, that shows that he had a student who, a postdoc who studied that, and she's at, I think, Texas A&M now, and we sent her some lights to mess around with. So that's real. And, you know, the trick is, what's the best way to engage that benefit?
Yep.
You know, those are efficient LEDs, you know, just as efficient as red. Do you need to have that with red and the far red? How much extra benefit does it get you? Right now you kind of pay a penalty because you don't get to count that output in DLC right now until they change the definition.
Yep.
But that doesn't matter. You know, we want to make what's right and what works, and so we're gonna be looking at that. And but yeah, it's our red is a deep red right now. It's 660 nanometers. Those are awesome LEDs. They're super efficient, and they make a lot of photons. So we're happy with that. We just need to understand, how much extra supplement should we be looking at in far red, like 730 nanometers.
For sure. What's your take on the latest and greatest UV products hitting the market?
You guys know I'm not a big fan of UV. So people like to just say, kind of wave their hands and say UV. We've got UV, and UV is a super broad spectral range. There's UVA, which is like black light, which is right next to violet, visible light. And there's UVB, which gives you sunburn, which is like 320 nanometers. And then there's UVC, which is, kind of centered around 250, 260 nanometers. So first of all, with LEDs, it's a lot easier to make UVA than UVB and UVC. The deeper you go into the UV, the less efficient the LEDs are. And so, this idea that UV is helpful comes from some old research from the 80s from USDA when they were studying like what the impacts would be of ozone depletion on crops when there's more UVB coming hitting the ground, and UVB, like I said, gives you sunburn. So that's like that wavelength of light. And so these researchers, put some in the 80s some fluorescent UVB lights onto some marijuana. And they saw, a little increase in I think it was THC. So that's where all this stuff comes from. And it wasn't just one researcher. Other researchers saw that, and their basic idea is like that these secondary metabolites are created as a defense mechanism to this damaging radiation. That totally makes sense. Fast forward 40 years. And here we are, and we have some LED manufacturers, putting out UV products. They're all UVA. So they're like 380, 390 nanometers, which is right next to 400 nanometers, which is basically violet. So the response isn't going to be different than basically a violet LED. It's not that special, right?
So you won't get those same effects that you got from the research. That's not it's not part of the UV spectrum.
No, it's not UVB. You gotta track that. And then the other thing about that is, the genetics from the 80s are different than they are now. So a lot of that, what the benefit they saw, it would be kind of in the noise with the latest genetics. So it's not clear that you're going to get that benefit at all. And we're making some UVB bars to test, and we'll figure it out. But early research from Guelph up in Canada University and from Bruce Bugby is UV. All the UV does way more harm than good. You just can't get it right.
It's not there yet.
Yeah, the plants don't like it. You're sunburning them, and you're not getting any benefit. Mm-hmm. And there could be a role for UVC for like germicidal for taking care of some mold and stuff, but it's super inefficient though, those sources. So there's still some more to understand, but right now I'm more interested in just the red, getting the red right, checking out the far red, and then we're making some sample UVB bars. Yep. And we're going to spread those out to some researchers and see what they say. But those LEDs are super expensive too, and they're not efficient. So it's those UVBs.
Perfect place to sell them is the cannabis market.
Yeah, no, that's why we haven't come out with it. Lux won't come out with a UV product just because we've tested it and we hadn't seen any benefit in Morgan's guidance.
If the research isn't pointing us in that direction,
we won't do it.
Then that's not the direction that we want to be pointing growers in.
No.
That's what I like about it here. It's like we can ignore the hype. We just go right to the researcher and then do our own research. Yeah. Based on what's coming out from the universities and what we're seeing in the from the best growers in the world, and follow our own lead and develop products that we know are gonna help.
Yeah, absolutely. I think that wraps it up. This is awesome. No, it's a pleasure having you part of the team. I know Brent and I really value the time we get to spend together.
We were like some lost little kids
Yeah.
wandering around. You know, we
Yeah.
did a great job with some HPS. You know what I mean, Brandon, and decades of cultivating, and Ivan and the crew, and knew that through and through. And
Yeah, we knew HPS, no problem. I mean,
Yep.
producing the Lux D1000s, producing 26, 27% more PPFD on the canopy. That's an easy read, right? When you have a PPFD meter and you're testing against these other lights, but then when you go into LED, diode, bin count,
manufacturers.
I mean, this is a whole new ball game.
Yeah, the world running out of diodes.
Yeah,
You know what I mean?
So bringing Morgan as part of the Lux team and having him as full time, working with us daily, working with our design team it's vital. You cannot do it without it.
You can help us make the world's best LEDs, Morgan.
That's what I'm here to do. Brent said when I was starting that he's giving me the keys to the Ferrari, and that's what it is. That's what we have here at Lux. And then getting to work with guys over at Jungle Boys, best growers in the world, and some others. It's like dream come true. You get all the pieces. You get to connect and try stuff that no one else in the world can do.
Awesome. Thanks for your time today, man.
Thanks, brother.
Thanks, guys.
See ya.